Question now about net torque for grade 12 physics. It doesn't look like a torque question, but the way we're going to solve it is by incorporating our net torque relationship. So we've got two individuals that are crossing a big crevasse. They placed a 3.6 kilogram ladder across it. The edges are 4.1 meters apart. First climber starts and reaches a point 1.8 meters from the edge. The mass of the climber and her gear is 87 kilograms. So with what force is the ice on each side of the crevasse pushing up on the ladder? So the answers here are written for you. So the 392 on the right and the 497 on the left are the answers. We're going to try and work out to get those answers. To figure it out, I'm first going to label all the forces that are in play. So there's two upward forces, one for each of the kind of on the edge of the ladder. I'll draw that at the end of the ladder so it makes sense with the problem. There's a force of gravity from the center of mass of the ladder, and there's a force of gravity from the hiker walking across. So 4 forces in play, and I'm just going to label them from left to right: F1, F2, F3, F4. Make my F3 a little clearer. Okay, not that much clearer, but you get the idea. So if I add up all my forces here, I'm not going to be able to solve for F1 and F4 because I don't have enough information. I've got one equation and 2 unknown variables. That just doesn't work. That's where the net torque relationship comes in. So I'll write my net force equation out first because I'll be coming back to it. All the forces added up. Now my net force has to work out to be 0 because it's static equilibrium. Nothing's moving, nothing's accelerating. Everywhere there's a force, I have a torque value. So there's F1 there, there's torque 1, and it would make this rotate depending on where you put your pivot point. So my pivot point will be right here at the end of the ladder. Tempting to put the pivot point in the middle, but remember the idea of using net torque is to eliminate one of the unknown variables from our equations. So put the pivot point at F1 or F4. And so that's the same for all types of problems like this. Put the pivot point where there is an unknown force. So torque 1 at the pivot point will be a 0 torque. F2, on the other hand, will be a torque. And it would make this rotate clockwise. So that would be a negative torque value. I'll make that whole thing a little bit clearer. So I've got F2, I've got a torque 2, and it would make it rotate clockwise. So that'd be negative. Force of gravity here has a torque 3. That would also make it rotate clockwise around the pivot point. F4, call it torque 4, and that would make it rotate counterclockwise, and that's positive torque. Remember, the torque negatives and positives are based on rotation. So using our net torque relationship, write that down now. Get rid of that. Just still 0, so it's all the torques added together. So net torque is 0. Torque 1 is 0. Torque 2 is going to be negative, and it's the distance from the edge, which was given to be 1.8 times the force that's acting on it perpendicularly. It's a 87 kilogram person, so times that by 9.81. Torque 3 is negative. It's the middle of the ladder. The ladder is 4.1 meters stretch, so 4.1 divided by 2 is 2.05. Again, times the mass of the ladder. Forget what that is, 3.6 times 9.81. So the only unknown variable will be our F4. For some reason it says F3 up here. So it is a distance of 4.1 away, and F4. There we go. So punching this up in the calculator. 1.8 times 87 times 9.81. 536 Minus from that, 2.05 times 3.6 times 9.81, 72.4. Add to that the 4.1F4. All right, so just be rearranging carefully and solving. We have 1536 and 72.4 divided by 4.1. We get 392, which is good. That's what we're supposed to get. It's our upward force on the right. We go back to our net force equation to figure out F1. So now that we've figured out F4, the only unknown variable will be F1. Remember F net equals 0, so 0 equals F1 plus force of gravity from the ladder will be negative 87 times 9.81. Remember, once you go to a force problem now, you reset your coordinate system to be up, positive, down, negative, and then don't worry about the rotation stuff. Force of the ladder, it's a 3.6 kilogram ladder times 9.81. F4 is upwards, so it's positive 392. When you solve for your forces using torque, you're always going to get the magnitude. So if it's a up or down arrow, you got to make sure to, or up or down force, make sure you put it as positive or negative correctly. So working this out, you should get 497, so we'll just make sure the numbers work. 87 times 9.81. That comes out to be 53.5. Another one, 3.6 times 9.81. Can't work the calculator today. There we go. 35.3 plus 392. So, rearranging, solving for F1, careful with their numbers. We get 497.